So a quick one, in this video we're going to be doing engineering maths on piecewise function continuity. Welcome to this video. This is just to broaden our horizons on how to solve continuity. There's some continuity that will deal with unknown. They can give you to find the unknown. So now, in this case now, we are asked to find a and b that makes the piecewise function fx this continuous everywhere. And we know that for a function f of x to be continuous, that means the f of a, that is the f of the number, and the limit as it turns backward and forward will be all equal. So now to solve this, we are following just 3 steps quickly, no patching of anything. The first thing is to identify the continuity points. And what are the continuity points here? We have 2 and 5. Those are what that x is turned into, the 2 or 5. Now we are going to find continuity for 2 and find continuity for 5. So it will lead us to simultaneous equation. So when we identify the continuity points, we are going to equate 2. Either you take the f of a value and the limit as it turns backwards, or you take the both limits and equate it to each other. We are going to do that and get your equation 1. Then for the other number 2, you get your equation 2. Then you solve simultaneously. Without wasting our time, let's move forward. Now identify continuity points. So we have continuity points for f of x. Let me say x is equals to 2 and x is equals to 5. So x equals 2, x equals 5. We have continuity as x equals to 2 and continuity as x equals to 5. Now we can now start. Equate either of, if you want to choose f of a now, you can ask, but I prefer using limits, but let's use everything, it is all the same. So f of 2 now will be what? That means in this condition, which one is telling us that x is equals to 2? Let's search for it. Here it is x less than 2, we don't need it. Here it is x greater than or equals to 2, so we are using this condition, which is ax plus b. We have ax plus b. And what is x? 2. Put 2 there. That will be a into brackets 2 plus b, which is 2a plus b. We've gotten f of 2. Now we need one more out of this function. I can either use the backward or the forward. So I choose to use the forward because everything is the same. So let me do f of limit as x tends forward, that is a plus. So this one is telling us that x is greater than a. It's telling us that x is greater than a. Now what do? X is greater than a. We search for the condition that satisfies that a. This one is x less than 2, we don't need that. This one is x greater than or equals to 2 and less than 5. So here again we have ax plus b, which is still going to give us 2a plus b. Now let's do the last limit, which is for the minus. Now x tends to a backward, and this is what is going to satisfy that, because x is less than 2, that means it's moving backward. So we are using this, which is going to be x squared plus 1. So what is x? 2. That will be 2 squared plus 1 equals to, this will give us 5. Now we can use any of this equation. We've gotten 2a plus b, we've gotten 2a plus b, we've gotten 5. I can choose to use any of this equation to solve, but to make the equation simple for me, since I have a constant here and I have these two as the same thing, they are all equals to the same number, but we want to take the one that will satisfy us and make our work easier. So I will take this limit turns backward, and I will take one of this and equate it to each other. So what am I saying? I'll be having 2a plus b, this, and equals to 5. I'll satisfy equation 1 like that. That is equation 1. So I'll go and do the same thing for 5 too. As x, continuity as x equals to 5, I will come here and I will come and search. What is f of 5? What will be f of 5? That is when x is equals to 5. Now where is x is equals to 5? This is it here. Greater than or equals to 5. So I'm using this to be 2x minus 3. And what is x? 5. So we have 2 into brackets 5 minus 3, which will give us 10 minus 3, that's equals to 7. Right? Now let's take the limits. Limit as x takes a plus. This a, I can decide to put 5. I'm just putting a there so that it's still the same thing. If you put 5 here, we are still talking about the same thing. So as it tends forward, that's greater than 5. What's greater than 5 here? Yeah, it's still the same thing. So I'm still having 7 here, since it's still the same stuff. Now let's do for minus. Limit as x tends backwards. So that will be equals to the one that this one now will be less than a. That means less than 5. So what is less than 5 here? It is here. X less than 5. So we are using this, which is going to be ax plus b. And what is x? 5. That means a 5 plus b. So which is 5a plus b. Now we have the 3 limits. We have the 3 limits. We have for the backward, we have for the forward, and we have for the f of 5. Like I said, I have 7 here and here. I will just pick the one that is different so that I'll be able to use the simultaneous equation. So what am I driving at? I have equation 2 now. 5a plus b equals to what? 7. That will be my equation 2. Now we are good here. We are all familiar with simultaneous equation. It is very, very, very easy. So, and I can just use any method I like. So I choose to use the elimination method. So if I use the elimination method, I will just say, okay, there's minus here. I will just say 5 minus 7 equals to minus 2, and equals to b minus b has gone. That one is cancelled as that it has been eliminated. So 2 minus 5, that will be minus 3a. So you know I've gotten my a like this now. Just say a is equals to minus 2 over minus 3, which is equals to 2 over 3. Now, what remains now, we have gotten our a as 2 over 3. I will just insert a into any of the equation and get my b. So I'll just say 2 into brackets 2 over 3 plus b is equals to 5. Now, I'm using equation 1. You see. So now, multiply, you have 4, 2 times 3 is 4 over 3 plus b equals to 5. We get. So now this 4 over 3 can come to the other side and become minus 4 over 3. So we have b equals to 5 minus 4 over 3. And that's an LCM. So let's continue from here. We just say over 3, and 3 is over 1. 3 divided by 1, that's 3, multiplied by 5, that's 15, minus 3 divided by 3, that's 1, then multiplied by 4, that's 4. So we have 11 over 3. So we've gotten our a. Our a is 2 over 3. Our b is 11 over 3. 11 over 3. So that is the answer for this. Shortly, let's do the second one. Now that we have been familiar with the steps, I will not just write a lot of things again. I will just pick the two limits I want to use. So I pick the upper limit, the backward limit, and the forward limit. Now, firstly, identify the points. And what points are we having here? We are having point 1 and point 2. So I just say x equals to 1, x equals to 2. Now, the formula, I'm going straight to the formula, and that will be limit as x tends to 1 backward equals to limit as x tends to 1 forward for this part. Then in this part, I'll just say limit as limit as x tends to 2 backward equals to limit as n tends to 2 forward. What we are doing here is that we are equating any of the two limits. You can also choose to use the f of x, but since these two are always different and they will give one will give us a constant, one will give us a expression, so that's why we are using these both limits. Are we together? So now we can continue. Now we just go straight to the point. For x tends to 1 minus, that's x greater x less than 1 minus less than 1. So we are using this. That is x plus 1 equals to x greater than 1 that we are looking for here. So here we have x greater than or equals to 1, then less than 2. When you are reading this, you are reading it to the back. You don't read it as less than, it as greater than. So x is greater than 1. You are using this ax plus b. Now let's solve. X here is 1, remember. So this 1 plus 1, that will be 2 equals to, here we have 1a plus b. So just have a plus b there. I'm inserting x, that's what I did there. So here we come here now, come and do the same thing. Less than 2. X is less than 2 minus less than 2. So this is it here, less than 2. We are using this. Equals to greater than 2 or plus greater than 2. Now you can see we are using this 3x. Now what is x here? 2. So we have 2a plus b. Then here we are having 3 times 2. 3 times that's 6. So now we have equation 1 and equation 2. What are we going to do now? We have to solve. Should we use elimination method also? You can just arrange them. Just say a plus b equals to 2 and 2a plus b equals to 6. And use the elimination method. You can also use a substitution method if you are interested in that. It is all the same. So now we have a minus a 2 minus 6, that will be minus 4. B minus b, that one is gone already. So a minus 2a, that will be minus a. So automatically we know that our a is equals to 4. So what do we do here? Insert a in any of the equation you like, any of the equation. So I can choose a, equation 1. I'll just say 4 plus b equals to, right? Because a is now 4 now. What again now? So we just bring this 4 here. So I will say b is equals to 2 minus 4, which is equals to what? Minus 2. So the reason why the first one was lengthy was because I was explaining the steps. But this now, since we are familiar, we know better. So our a is what? 4 and our b is minus 2. Thank you very much. This is the end of this video. Look out for more of this on engineering maths. Thank you very much. Make sure you like, subscribe, share and comment. God bless you.